Welcome to the session. Greeting of the day. In today's class, we are going to talk about a dye-penetrant inspection method. Out of these non-destructive methods of all visual, liquid, magnetic particle, current, radiographic, ultrasonic, acoustic emission, infrared thermography methods, in this class we will talk about this liquid penetrant testing methods. So here we want to say about this one. So in the liquid penetrant testing method, there is some procedure. As we already discussed this from the 1900s onwards, they are using some other chalk powders, carbon blocks, kerosene, oils, and some other developers, fluorescent. Slightly we are coming into the trends. Based upon these developments, the basic process of steps involved on the dye penetrant inspections are as follows. It is nothing but the first a surface preparation to be done, such as for a cleaning treatment, surface for cleaning treatment. Second one, we are doing some penetrant application. So then the penetrant applications we have to do. So here we are talking about two important technical words of a penetrant application. After that penetrant dwell time, we should give some time to this penetrant to get into this cracks. That's why we are giving a penetrant dwell time. Then the indication development, so the same. The penetration development and the excess penetrant removal. Then the second technical term I am using here as a developer. So we are using a developer for applications. Then the indication developer have to apply and it should indicate outside for visibility. And then with respect to the visibility, we are going for inspection. After inspection, the material to be cleaned also. So material to be well cleaned. So because it should not corrode or this chemical reaction should not affect those inspecting part material in future. Therefore, proper cleaning to be done. So the penetrant is nothing but it will penetrate into the crack. We will see. So this procedure we have to follow to do the penetrant test. After doing, we should inspect by seeing this contrast color, and then we should justify if it is yes, no, available, non-available, we can pass or fail, it is in the range or not in range, all those things. Number one I have taken. So out of this step one, it is nothing but a surface preparations. So surface preparation, you can see these images. There is a small crack in the specimen. This is the total thickness of the specimen. Out of this total thickness of the specimen, it is the surface. So it is the surface. If in case this crack is available at this point or somewhere here inside the subsurface, it is not possible to identify through this dye penetrant inspection method. But the crack is available at the surface and coming through the surface. And it is coming through the surface. Therefore, it is touching the surface. By using some other methods, you can apply penetrant and we can identify the contrast colors. So that's what we are going to do now. If it is not touching the surface, not possible to detect. As because it is touching the surfaces, it is easy to identify through dye penetrant inspection method. So that is what initially we want to clean the surface first. This surface. Most critical step for liquid penetrant inspections is that the surface must be free of oil, free of grease, free of water, free of other contaminations like dust particles or anything. We should prevent them because it is also will not permit this liquid penetrant to go inside the cracks. Therefore, it should be cleaned properly in such a way when we are applying the penetrant, it should go inside the crack and it should reflect that we can able to see. Therefore, we are cleaning all these things. We should not be obstacle. That's important. Therefore, we are cleaning. So that may prevent penetrant from the entering the flask. So it should not stop us. So therefore, we are doing. The sample may also require etching if needed. If some mechanical operations, such as maybe a machining process, maybe a machining process maybe a sanding or grit blasting and maybe a sand blasting have been performed because these operations can spread material. So during machining some materials are coming out. During sanding, grit blasting some materials are coming out. So that materials will be on the surfaces only until otherwise it is cleaned. So if not cleaned and going for inspection, this material which is come out through the machining and through the sanding, through the grit blasting or maybe sand blasting, sands may be. So all these things will be on the surface only. When with respect to that we are applying the penetrant over that, it is going to block, and therefore we are not possible to inspect those cracks. It is missing. It is not visible to our eyes. Therefore we should make it visible. Then only it can be identified by us. Therefore we are subjected to cleaning of action on the surfaces first. So surface is very well cleaned. Now we have done this one, completed. So we have done this one, we are going for second one. So penetrant application. Now we are after cleaning, we are going for the penetrant application. Once the surface has been thoroughly cleaned and dried, because we are going to apply penetrant, on the dried surface penetrant has to be pasted, some gripness, surface tension and absorbing property we have seen for capillary action. Those things we are creating here. So this material and the surface has some gap. This point has to be in contact. Surface tension should be in contact with the specimen. If there is no contact, how it will flow out? So therefore that we have to create by drying, and then penetrant material is applied by spraying or brushing or immersing. So maybe we can take like a painting brush, we can take a brush and spray, or we can use the brushes to do spray methods to do spray, or otherwise we can immerse in the long bathtubs, like tubs we can be able to insert in tank. On the tank we can dip and take out. So something, anyhow the penetrant is to be subjected on the specimen. If it is penetrant is subjected, and the penetrant will go inside the cracks. So part is the penetrant bath. So the penetrant is going inside the cracks and the porousness. Maybe here, maybe one, maybe porous, maybe others, something else. So likewise, the penetrant will go into inside now. Now this is step 2. In this image, you can see we are spraying. Spraying method is used there. Spraying we are doing such a way, this red color liquid penetrant is falling over the surfaces, and somewhere on the surface we have a crack. The liquid penetrant is flowing into that crack also, and then we have to clean them. So the crack with the liquid penetrant is inside, it may not be come out. Therefore that is the idea. So we have done completed 1, 2. So number 3 we are going here. Penetrant dwell time. The penetrant is left on the surfaces for sufficient time to allow as much penetrant as possible to draw from or to seep into a defect. Anything we need some time to flow, a fluidity needed, a fluidity have to flow, and it is wanted to go in deep, a complete crack to be filled out. Just like that pouring and side by side cleaning, what happens? We are not given the dwell time to penetrate. Before penetrating itself, we have cleaned. Definitely it will not happen. Therefore, we are, after penetration applied, we should give some sufficient soaking time, like a dwell time we should give, so that it can able to take a whole area. So completely. So in the previous image you can see it is started, but it is not coming inside. But in this image you see it is started and it is completely filled up to last point of crack. So that is by giving up the dwell time only, it reaches up to the last point. Maybe multiple cracks also. Maybe here, any surfaces we should give some sufficient time called as dwell time. In such a way penetrant can be able to penetrate inside. So penetrant dwell time is the total time that the penetrant is in contact with the part surface. So until the penetrant dwell time is given, this penetrant is in contact with the surface under the cracks. After that, what we are doing? We are cleaning. So there is no contact. It is removed already. So that is what. So step 3 completed. We are going for step 4. 1, 2, 3. Coming for next one as the 4th one. Excess penetrant removal. So where it is excess penetrant? So we are seeing here This is what image what we see in the previous slide. It means dwell time. After dwell time, we are cleaning the surface where there is no crack. After doing the cleaning the surfaces, this part you see the penetrant is not available. So after this it is found like this format. After this it is found like this. So there is penetrant is removed, wiped out, but the penetrant which is wet inside the crack is not possible to take out because it's already inside. We are doing the cleaning operation only in this here, like this only we are doing. So like this only small cleaning operations we are doing. Here and here this process only cleaning operation. Slowly we are wiping out. We are not doing any sucking process. We are doing only cleaning process. So likewise only we are cleaning, and therefore this red color has been went outside. So that is what we are doing in this step. This is the most delicate part of the inspection processes because the excess penetrant must be removed from the surface of the sample. So excess part is removed. So what happens now? We have to take out only the excess penetrant. So only take out the excess penetrant. What is excess penetrant? It's available on the surfaces or excess penetrant. So not this one. So this is required which is inside the crack. We want to take out only the excess. Not that the penetrant which has already entered inside the cracks. So this is important. This we need. This we not need. So that only we are removing. Depending on the penetrant system used, this step may involve in cleaning with a solvent, maybe a rough solvent which is will not come depending on the material, it will stick over also. Therefore, cleaning through the solvent, direct rinsing with the waters may also sometimes will be very helpful, easily cleaning, or treating with a part with an emulsifier and then rinsing in the water. Any method we are following, maybe a solvent or emulsifier with a solvent or water and simple waters. Anything we can do, but the excess penetrant only have to be wiped out. So now the penetrant is inside. We finally in this fourth step we will receive the sample in such way. So now we are going to apply the developer, and this penetrant will due to capitalization it will come out, and we are going to inspect. So this is completed. Penetrant applied, penetrant dwelled, and the excess penetrant also removed. Now we are going for the developer application. So we want to apply developer. So step 5. A thin layer of developer, somewhat like a white powder, sprayed or brush. A developer is then applied to the sample to draw penetrant trapped in the flask. So penetrant is trapped here inside. That is the need I told you. This is important I told you. So this is wanted to trap out. So for that reason the flask back into the surface where it will be visible. So developer come in a variety of forms that may be applied by a dusting methods. Maybe a dry powder like putting a powders over there. We could have seen doing the roads at the corners, they put white powders. Such categories, powders, dry powders are there we can use, or maybe a dipping, or maybe a spraying actions. If you want to spray it, maybe a wet developers. It is a wet developers which is sticking over there in immediately because it is wet. On surface it will stick over in immediate. Then this penetrant and developer come into the contact. This part. So this part. So what happens? This penetrant will be absorbed by this white developer. So this will come here and it will fill here now. So let me see in the next slide. So step 5 over. So now we have done surface preparation, penetration application, penetration dwell time, excess penetrants removal, and the developer applications also over. So here also next indication. Now it means we have to give some dwell time here also. After developer applied also some dwell time because this penetrant have to be observed by the developer on the surface, which is on the surface, which is on the white color. So we are giving some these things now. Indication development. So indication development we are doing. So the developer is allowed to stand on a part surface for a period of time. So here also we are giving the dwell time also given. Here also some indication for development, some few minutes we are given. Sufficient to permit the extraction of the trapped penetrant out of any surface flask. This development time is usually maybe a minimum of 10 minutes we may allot. So just 5 to 6, 7 to 10 minutes. Significantly, a longer time may be necessary for a tight cracks. So normally a wider cracks the flow rate can be easy and comes out also easy. But for the tighter cracks, going inside also very difficult. At the same time coming out also very difficult. Therefore, we need such a more longer time than the 10 minutes for the tighter cracks. So now what happens, you see? So here, this is what the image what we seen already. Here you see it is coming out. So it is in the powder. It is going to absorb. So what happens? This red color is coming outside. The arrow mark you see coming out, and here it is reducing. So where the liquid what is available, the 100% is 100% always. But what happens when it comes out by the capillary action, here it is not available. So this zone you see, it is not available. But the same liquid is coming out and absorbed by the powder developer. It is here, it is absorbed. So it is absorbed here. Now it is visible now, because it is white and red forest over there. It is contrast color visible to us. Easy to find. So likewise, something it comes out and fills the. So now it is filled. So number 1, penetrant applied, penetrant wall, excess penetrant wall, developer application, indication, development also done. So now the 7th one we are going for inspection. This is the inspector's duty. So what for this inspection we have did this much steps. For the visibility, visibility is very important parameter. If the visibility is not there, how we can able to go for inspection? Inspection anyone can do. It is possible to do in the dark room. It is not possible. We need some bright features, bright lights. Then only it is cracks are visible. For that only in the visual inspection, important point bright illumination to be there. So likewise here also some contrastness to be there, then it is visible. So here we came to the 7th step as inspection. Inspection. Inspection is then performed under appropriate lighting. Important. So appropriate lighting is given here to detect indications from any flaws which may be present. So now I am giving some torch light spraying with respect to bright features of light. I am giving some light sources which may be present and which is possible to understand such things. So here you see here it is coming out and it is illuminating. So by even though it is also micro crack, we have done this process in terms of large cracks. Normal visibility is possible. Not even this lights are required. But the lights and these penetrants are required when the cracks become micro level. Therefore, we are come here for lighting sources. So, giving some proper lighting sources, and we can able to inspect from this point. So, likewise, we can able to do. This is one of the last step. So, next we are coming for as of now we have done this is surface preparation, penetrant application, penetrant dual, excess penetrant removal, developer applications, and then indications, 7th inspection. Now the inspection is over. Now we are wanted to do about this post cleaning process. So post cleaning, because it is the chemicals we are using, it may contaminate. To avoid those processes, we want to do the cleaning process. The final step in the process is to thoroughly clean the part. Part surfaces to remove the developer from the part that were found to be acceptable. The test surface is often cleaned after inspection and recording of defects, especially if post-inspection coating process are scheduled. So this is how we have done. First we have done surface. This process is done to avoid the corrosions. So the chemical reactions will affect the future material's property. If it is corroded, obviously it is waste. Therefore, to avoid those things, we are giving. We cannot able to leave as it is after putting chemicals on the surface and going out from it. It is too bad. So we should do a perfect post cleaning process is important too. So these are the various 8 steps. Surface preparation we have done. Then the penetrant applied. The penetrant dual we have given. Excess penetrant removal. developer applications, indication development, inspection and post cleaning. So these are the various things that we have did for did for die penetrant inspection methods. So you can see some of the original images. So this is how the penetrant applied over this material, penetrant spray, red color spray applied, and then we are wiping some cleaning process we are doing after giving the dwell time, then applying after the white color developer. See here, this is the part. This is the crack where this red color, here the crack is available. Here the crack is available. See, these are the various cracks available. After applying the white color developer, it is observed outside. By the capillary action is observed outside, therefore the white red color dots are micro cracks, which is not visible in the normal visual inspection. Not visible to naked eye. Therefore, we went to this die penetrant inspection, where it is after applying penetrant, dwell time, after applying developer, dwell time, and then it is absorbed back. Therefore, the cracks are visible. Now we can go for repairing of these parts. So, application, crack, cleaning, and then the developer applied, and then on the developer, the indications will form there. So, this is how a simple procedure, how we are doing. The advantages what we are going to see is high sensitivity with respect to small discontinuous can be detected. So even the small less than 0.08 mm also possible to inspect. This is one of the advantages. Few materials limitations. Metallic and non-metallic, magnetic, non-magnetic, conductive materials, non-conductive materials may be inspected. Any materials, a few, which means only non-porous material, not possible. Other than that, all. A few means porous material not possible, but all the materials are possible. Maybe a metallic, maybe a non-metallic, maybe magnetic, non-magnetic, conductive, non-conductive, anything. Just we are going to put the penetrant. There is no reaction takes place. Just color contrast we are receiving, and that's it. But the chemicals to be removed. Red color penetrant developer is something a chemical that should be removed. But with respect to chemical reactions, we are not doing. With respect to this capillary reactions and contrast colors, we are doing. A rapid inspection is of large areas and volumes. Even though we are giving some 7 to 10 minutes of dwell time, this is considered as a rapid inspection. As compared to the radiograph, you have to take photo, film will come, and then you have to clean, and then that cleaning after development, then we have to go for inspection by viewing the radiographic film. But it's not like this. We are the judges, we are inspectors, we are judging, but we are having the spray and then applying developer, giving some time. Within 10 minutes, the inspection is over. Because the dwell time is 7 to 8 minutes, then again, within 10 to 15 minutes, we can complete this inspection process. Suitable for parts with the complex shapes also can be done. Indications are produced directly on the surface of a part and constitute a visual representation of the flaws. Portable, maybe materials are available in the aerosol spray cans. So it is how for this doing this inspection only two things we need. One is the penetrant spray can, and one is a developer can. So when the two is there with some cloths for cleaning purposes, it's easy. First pre-cleaning, then applying of penetrant, again dwell time, then cleaning, then applying of a developer, then cleaning. It means we have to after inspection, post cleaning. So that's it all. So only two cans we need. One is a penetrant can, one is the developer can with some cloths to adjust. So that is a portable also. We can go with the pockets and we can go. So it is a portable material. So it is a low cost material and associated equipments are relatively inexpensive. What is this inexpensive? Only two cans we need with the cloth. So it is obviously inexpensive. No film like a radiograph, no gamma rays, no X-rays. It is nothing is available. It's a very low cost inspection method. It's a short time. Even though it has some good advantages, a few disadvantages are available. Only surface breaking defects can be detected. It means subsurface surface non-possible, so non-possible, and also porous. Porous also not possible. Only material with relatively non-porous surface. So see, it is given. Non-porous can be inspected. Porous means not possible. Pre-cleaning is critical since the contaminants can mask the defects. So it means what this mask word gives when the machining, grinding, any other material we are doing, it is masking over the surfaces. If you are not clean and just like that you are applying a penetrant, penetrant will not go into the cracks, will not penetrate into the cracks. Therefore, it is waste of time and inspection is totally waste. So therefore, it is masking where it is defects are not found. It is waste. Then metal smearing from machining. So see, it is machining, grinding and grit or vapor blasting must be removed first by using the pre-cleaning process. The inspectors must have direct access to the surface being inspected. So in the radiographic film, inspector no need to go there, because the operator, radiographer can go there and keep the film, and over the sample we can pass the radiographic and film will be developed. This film is enough to submit to the inspector. When it is submitted to the inspector, inspector will see this through the bright lights, and he can able to inspect and interrupt those things. But here it is not like that. Inspector have to go directly. We are not taking photo here. We are not having film permanent records. Not having. We want to post clean, pre clean, all things we have to do there itself, and inspection to be done directly one. So it is not a remote camera, digital method is not there. So this is one of the disadvantages where the inspector must be present in that location for inspection. Inspector will have to go there. Surface finish and roughness can affect inspection sensitivity. The multiple process operations must be performed and controlled. Yes, the post cleaning of acceptable parts or materials is required here. At last one, the chemical handling and the proper disposal is required, because we are using some penetrants and developers which are belongs to chemical category. Disposal of this required, pre-cleaning and post-cleaning. Disposal object is required in terms here. Therefore, these are some of the disadvantages we have to concentrate.
The three main items for liquid penetrant testing are cleaner, penetrant, and the developer. Here is one of the cleaners, and there I have a number of liquid penetrants with different brands from different companies, and some of them are visible penetrants and some of them are fluorescent, which is this one, and here we have a penetrant which is emulsifier, so it could be any of the penetrants as shown here. Here is an example of the developers from different companies and different types of developers, which can be non-aqueous developers, aqueous developers, or a dry developer, which is actually in this can. An important point on liquid penetrant testing is that the penetrant and the emulsifier have to be from the same family. Intermixing of penetrants and emulsifiers from different manufacturers is prohibited. Cleaner and developer do not have to be from the same manufacturer. Here are some more accessories that will be required. We have the black light here, the light meter to check the visible light or the black light intensity, a brush to apply the penetrant, a water nozzle for water washing, a pressure gauge to check the pressure of the water, that it does not exceed 40 psi, and a comparator plate for qualification of the penetrants. In summary, the basic steps of liquid penetrant testing are shown here in this diagram. Cleaning, applying the penetrant dwell time, which is about 5 to 10 minutes, removing excess penetrant using one of those 4 methods, water washable, emulsifier, or solvent removable, and then applying the developer, which is right here, and after the developer dwell time, we do the examination for detection of the indications.
Spot check is the Step 5 is to inspect the part. Large cracks appear quickly as vivid red lines. Small cracks show up a few minutes later. If the crack is wide and deep, the red indication will be correspondingly large.
Summary. We have seen regarding the dye penetrant inspection. In this we have seen some 8 steps. How the procedure, how this process has been taken place, and some of the advantages and disadvantages of dye penetrant inspection we have seen. The remaining part of the subjects we will see you in the next session. Thank you.